If you've driven up Paint Creek Road the past few weeks, you may be wondering what all that heavy equipment is doing down in the creek near the Holly Grove Bridge. It's a stream restoration project to correct a problem that's been more than a century in the making. Decades of mining and logging in the watershed have caused sedimentation from erosion and runoff to fill the creek with silt, degrading the water quality, increasing the temperature, and causing loss of in-stream habitat.
If you really look at the cobble and substrate material that you see here in this lower end of Paint Creek, you'll see it's embedded. It's an official biological term, but it means it's surrounded, the sediment, the stones are surrounded by fine organic matter or clays or silts. So in order to have a good fisheries habitat, you want to have access for macroinvertebrates to get underneath those stones, and then they're the food. The start of the food chain is, the grazers are eating the moss or the algae off of the stone, and then they wash downstream as if you was trout fishing, and you catch them on a fly. That's a mayfly, stonefly, caddisfly. So you increase the biomass of the food source, and therefore you increase the biomass of the fisheries, right, which everybody likes.
Restoring aquatic habitat is just one part of the project. These stream structures are designed to speed up and redirect the flow, reestablishing and deepening a channel.
It purges the siltation out of the creek, and when the siltation fills up a creek, covers the rocks, there's nowhere for the stream to flow except up and out onto a floodplain, because the stream is shallow, it's not deep. And this stream structure creates channels and purges the silt out, so now you have channels, which if you notice in the creek, there's no channels here because it filled up with silt. So when you establish a channel, the water level on the banks drop because the stream is deeper.
Placement of those in-stream structures is far from random.
You build within a tenth, horizontal and vertical, of what the engineer has designed. So a tenth of a foot vertical, tenth of a foot horizontal. So that far. When you are building a stream channel, you have to have an elevation that maintains the structures that you're putting in the stream channel. So if you build them too high, there's a thing called shear stress, that the force of the water during a flood event, if a structure's too high, pushes those stones or the wood and has a chance of spinning that material. So you need to have a perfect slope on these structures in order to maintain structural integrity. So the more accurate you are from the design, the higher probability that structure does its job forever.
Attaining that level of precision can be difficult in West Virginia's steep, narrow valleys where GPS isn't always an option.
We have to be visible and see enough satellites to be accurate. In southern West Virginia, we rarely have that opportunity to use our GPS. So we were the first company in the country for TopCon to use what's called an LPS. And that's a local positioning system. And that uses a total station. It follows that prism that's on the back of that excavator. So then it passes a radio signal to the computer that's inside of the machine that shows the operator exactly what the engineer designed.
This is another one of those Cypress projects we've been telling you about over the past several months that were funded through the use of unclaimed settlement funds associated with the Freedom Industries class action lawsuit. A judge awarded a portion of those funds to 6 watershed groups to be used for the protection and restoration of watersheds in the counties affected by the January 2014 chemical spill that disrupted the water supply for roughly 300,000 residents. In Hansford, I'm Mike Huff for Environment Matters. Thanks for watching.